Today's lesson is 5.5, solving rational inequalities, and it's not as bad as it looks. This looks kind of foreboding because it's fractions and everything, but it's really not. You guys have the skills for most of this already. So the question is determine the solution set. The first thing we need to do is state restrictions. So the restrictions are x cannot equal 3 over 2, that comes from the first denominator, and x cannot equal 5, that comes from the second denominator. We're going to create an inequality with 0 on one side. We can't cross multiply here. Let me just explain that a little more. So cross multiplying would be multiply diagonally across here and across here to get rid of the fractions, but you can only when you're certain that each denominator is positive can you multiply both sides by the lowest common denominator or cross multiply. Otherwise you need to reverse the inequality sign. So some of the strategies we've used before don't work here. That's because if you remember your work from inequalities, if it turns out that our denominator is a negative, let's say that x is 2 and we get a negative 3 here, then actually what I'd be doing is multiplying both sides or cross multiplying by a negative 3, and when you have an inequality, that means you have to reverse it. Remember, when you multiply or divide by a negative sign, you have to reverse the inequality. Since I don't know what x is right now, I can't do that. So the safest bet is to not try to eliminate the denominators. We need the restrictions anyway, right here. So I don't want to try to get rid of the denominators when I have an inequation. So what I am going to do is bring everything over to one side. So I have both terms on one side. And now I have to simplify. That means the lowest common denominator, collect all that stuff and everything. So what's the lowest common denominator here? It's both parts. So this side, this term needs an x minus 5. This second term needs a 2x minus 3 so that our denominators will be the same. So now I have a common denominator. I can put it all over one denominator. And I can I can distribute all of these pieces here, distribute here. Now be careful, there's a negative. So when I distribute, or a FOIL, or a binomial expansion, when I expand these two binomials, I also have to remember if I'm going to do it all in one step to bring the negative in at the same time. So these signs are all changing. So when you're doing this, as you're doing it along with me, make sure you're bringing that negative in as well. Okay, so we have simplified, we've got our numerator all on one side, all together, one piece. Now we're just going to collect like terms in the numerator. So we're still on step 3, which is to simplify. And we get a nice little binomial in the numerator, which it just so happens it can factor. So we take out the greatest common factor of a negative 2 and we're left with 4x plus 1. So here is our simplified rational inequality. So all the math that you did here, there's nothing new. You've done the common denominator stuff before and the collecting like terms and the factor. Nothing here is new. We haven't done any new kind of algebra or anything yet. But the question said we have to determine a solution set. Now we're used to saying this equals 0. We're used to that, but now we have greater than or equals 0. So I have to look at the important pieces here. The numerator, I have an x-intercept at negative 1/4. So that's an important x value. An x-intercept is very important. On the denominator, I have vertical asymptotes. Those came from my restrictions. So those are all really important pieces of the graph. Now we're not graphing it. What we're just doing is looking for the solution. So the solution means what will x be so that this whole thing is greater than 0. So if you're imagining a graph, imagine a weird rational function, all kinds of asymptotes and curves and weird strange things. But that whole graph, I want to know where it's above the x-axis. That's what greater than 0 means. I want to know where this is all above the x-axis. So that's what I'm trying to figure out. And these pieces are really important to solving that. So the next step, Step 4, is to use a plus minus chart. Now we've done this before, but I'm going to go over it slowly. The first thing for the plus minus chart is all of these important points that are here. I want to put them across the top of my chart. So they're my important numbers, and I'm going from negative infinity to positive infinity. So think of this as kind of a number line. Everything's in order. Negative infinity, negative a quarter, all these are in order, low to high. So these are my important x values. Now down the side, I'm going to put all of my factors, all of them. Even that -2 is a factor. Every factor goes down the side. There's a -2, 4x plus 1, 2x minus 3, and x minus 5. So there's all my factors. So now that I have that, I can kind of throw a chart in there. Oh, f at x at the bottom, sorry. There's my chart. So the next thing I want to talk about is what we're going to put in the chart. So I set this one up a little bit differently than I have in the past. I'm going to use white, I think. On the first block here, I'm going to look for a number. So I'm going to put a test value in this first row. So I'm looking for a number in between -infinity and -1/4. And I want an easy number that's easy for me to use. So let's say -1. -1. Now in between -1/4 and 3/2, if you remember, I told you before, if you have one number that's negative and one number that's positive, a number in between them, we want to pick 0. In between 3/2 and 5, let's pick 3. In between 5 and infinity is 6. You could pick whatever numbers you want there. So I have my numbers. Now I have my test values. I'm going to sub them in. So this might be the first time actually we've had a constant here as a factor. Over here we had a -2. So I can't sub any of these numbers into a -2 because it's a constant. So what I'm going to do is that whole row across from the -2, -2 will always be negative because I can't, there's no x there, I can't sub in, it will always be a negative. I'm not sure, that looks kind of faint. I'm going to just switch to black here, I'll go over top. Negative, these are all negative. My next factor from so this is like my related function here. I'm calling this f at x. This is my related or my corresponding function. I'm just looking at this piece right here. My next factor is 4x plus 1, so there's a 4x plus 1. I sub in a number in between -infinity and -1/4, which is -1. I sub it into 4x plus 1, and that's going to give me a negative value. So I'm just going to put a negative here. So I'm going to work my way down this -1 column here. I'm going down here. I sub a -1 into my next factor. I'm getting a negative again. I sub in a negative to x minus 5. There's another negative. And so my final answer is here, f at x. I'm going to put an extra line across here to show that it's kind of a total. I have 4 negatives in that row, 4 negatives together. A negative, a negative, a negative times a negative would give me a positive. Positive. Okay, now let's sub in the 0. So I'm up here, look at the top here, I'm at the 0. I'm going to sub in 0 into everything. I already did the first row. 0, this gives me a positive. 2 times 0 minus 3 is negative. And the last one is also negative. So I have 3 negatives here. So 1, 2, 3 negatives and a positive. That's going to give me a negative final answer. So just to remind you of what we're doing here, it's like we're taking this number, 0, and I'm subbing it in here, subbing into this 0, 0, 0. If I subbed it into the whole thing at once, I would get a negative answer. I don't care what the number is. It's just that it's negative because negative tells me that's below the x-axis. That's what that negative is saying. When I sub in a 0, I'm going to be below the x-axis. Okay, what about 3? We sub in a 3 into all of these pieces, and the first one is negative. We've already established that will be negative, positive, positive, and a negative. So that altogether gives me a positive value for my entire function. We sub in a 6. The first one is of course negative because -2 is always negative no matter what I sub in. But into the next factor, it'll be a positive. The next factor is a positive, and x minus 5 is positive. That gives me a negative. So the question is asking, determine the solution set for the inequality. So it's not just a solution, it's not just one answer, it's a set of numbers, an interval. I was looking for where this related function, which I called f at x, where this corresponding function, this whole thing was greater than 0, greater than the x-axis, meaning whatever this function looks like, I'll draw a little sketch under my box here. Whatever this function looks like, I'm just going to, this is not what this function looks like, but we've got some, let's just say it was like this, some kind of weird cubic. Where is it greater than 0? Well, this one is greater than 0 here and here. So that's what I'm looking for. I'm looking for where this function is greater than 0. So my chart tells me that. This tells me where my function is positive, where it's positive. So these are my two answers. So my answers are in between negative infinity and negative 1/4. It'll be positive there. My graph will be above the x-axis. And between 3/2 and 5, my graph will be above the x-axis there. So writing that out, let's use interval notation. Interval notation is, so we have x is an element of a round bracket for infinity, always positive or negative infinity is always written with a round bracket, comma, so to the next value is negative 1/4. Now, does that get a square bracket or a round bracket? Look up to the original question. I'm going right up to the original thing that is typed. That does not include an equal sign. There's no or equal to there. So I'm not going to have a square bracket. I'm going to have a round bracket. So that's got to be a round bracket. So I don't even have to think about it. I know it's going to be a round bracket because of my original notation. Also, the other piece is 3/2, from 3/2 to 5. And they also get round brackets for two reasons. One reason is that the original question is a greater than, not greater than or equal to, but also they were asymptotes. So I wouldn't be able to include those values anyway, because at the asymptote, my graph doesn't exist. So let's try to get a visual on this here. Just remember that you can't, this red box here, you can't cross multiply these fractions. It's tempting, but you can't because well, now we know our values for x, but some of them can be negative, so we can't cross multiply here. So this was the solution that we had. That's set notation, what you're seeing there. Would it have the same solution if we had moved all terms to the opposite side? So let's do that and then we'll look at a graphical answer. So this one I want you to try on your own. I will just start it off for you. So I want to see if last time I brought this x plus 1 term over to this side. What if we have the same restriction, sorry, right there. What if we bring everything, the first term over to the other side? So everything's on the right side now. So this is a different setup here. So I want you to do all of the work that we just did on the other side. This is your practice here. I will show you the answers in a second after you press pause, and we'll see if you got the same answer. So press pause here and finish the question. Okay, you're done. So let's see the next line. There's our common denominator. It's the same common denominator we had before, but our signs in the numerator are all different. We get x plus 2 in our numerator this time. We have a greatest common factor there of 2. So we're looking for, here's our new f of x, here's our related function. 0 has to be greater than this, right? 0 has to be greater than our related function this time. And we have, so here's our important points. Our important points are the vertical asymptote at 5, the 0 at 3/2, and sorry, the vertical asymptote at 3/2, and a 0 at negative 1/4. So those are important values like we had last time. I'm going to show you something a little different this time. You can create a plus or minus chart here, or let's try this method. We're going to draw a number line. So on the number line, this is a little faster than the chart. On the number line, I'm going to put in my important values, just like I had before across the top of my chart. So this side is negative infinity, and on the right side, we're going to positive infinity. On the line, I'm not going to space them out to scale, but in order, I'm going to put all of these important values here, but I'm going to put them in order. So negative 1/4 is my lowest number. Then I have 3/2. See how I'm just spacing them out? I don't, I'm not trying to make the spaces equal. I'm just putting the important numbers on there. So there's all the important terms. Now instead of doing a whole chart, what I'm going to do is pick a number like I did before, a test value, and I'm going to sub it all in at once, kind of in my head. So the first thing I'm going to do is I'm going to think of a number in this interval here. So we can use the same one we did before, which is a -1. So now I'm going down to my function. I'm going to call this whole thing f at x, down here. And I'm subbing in a 1 in my head. So everywhere I have an x, I'm going to sub in a 1. You don't have to do it in your head. You can, of course, write it all out. When you sub in a 1 everywhere, so this, you have a 2 here, that's positive. This is positive, this is negative, and this is, whoops, negative there. Made a mess there. I just fix that one there. That's negative in the numerator. So I put all of those in without doing a whole chart. It's the same process, but I'm just doing it a little more quickly. I've got 3 negatives and a positive. That means when I subbed in a -1, I got a negative. So this number line, I'm also going to think of it as above the number line is anything that's positive. Below the number line is if our whole function is negative. So I'm going to put a check mark here. I'll use blue. A check mark here below to show that when I subbed in -1, I got a negative overall. So now you do it again. Pick a number in between -1/4 and 3/2. So in between these two, I might pick 0. It's easiest. So when you sub in a 0, you go back down to your, you erase all these other ones here. I go back down to my little related function. Everywhere that there was an x, I put in a 0, do all that in my head, and I get a positive. So I will put a check mark above the number line. Pick another number between 3/2 and 5, sub it all in. So we're doing the same thing we did before in the chart, right? It's just a little more condensed. I get a negative. Sub in a number greater than 5, like 6, put it in for all of the x's. It doesn't matter what the number turns out to be, only if it's positive or negative, and it's positive. So now let's look at the what we're looking at here. I'm taking that f at x, I'll just rewrite this piece. What we have here is 0 is less than f at x is what we're looking for. Or sometimes it's easier to think of that as, let's move it around, f at x. And I'm going to put I've got to have my arrow not pointing the same way, but directing the same way. So the small part of the arrow goes to the f at x. The large part of the inequality goes to the 0. I'm looking for where my function is less than 0. My function is less than 0 here. I'm highlighting in yellow. And here, that's where my function is less than 0. So in this case, I'm looking for where the function is below the x-axis. So my answer here, where my function is below the x-axis, is when I've got this piece, which is when x is less than -1/4. And this piece here is 3/2 is less than x, and that's less than 5. So that's another way of doing the same kind of question instead of a chart. So what have we got here? Here's the graphical solution to both options, and they're showing the corresponding the f at x part after I put it all together. So I put it all together on the first example, it looks like this. Put it all together on the other side of the inequality, it looked like this. And when I graph them, look at the graphs, they're really, I mean, they're symmetrical, right? But they're, they're reflections of each other, but they're not exactly the same. But remember, for this graph, we're looking for where the graph is greater than 0. Here's my x-axis. Where is my graph greater than 0, greater than the x-axis? So it's greater than it right here. I'm highlighting from the left. It's greater than it right to there. It's greater than the x-axis. This whole part here is greater than the x-axis, and that's it. And that's what the answer is showing. If you look at the bottom, I'm highlighting it. This whole part here is showing you the same thing. But the second time we did it, the second time, we talked about where the inequality was in the other spot. So we're looking for where it's below the x-axis. So where it's below the x-axis is here and here, which is exactly, comes up with the exact same solution. So the question says, does the solution set work for both graphs? Yes, it does. So it doesn't matter which side you bring all of your terms to. It does matter if you had to graph it, you would have a different graph. These graphs are different, but the answer is the same. So the graphs themselves look different from each other, reflections of each other, but the solution is the same. Where you're looking for either where it's all above the x-axis or below the x-axis, you're getting the same answer. Now here's a graph of the original question. Instead of me doing a corresponding, here's the original. So in black, just this piece here is in black, and there's its asymptote in black. And then in blue is the right-hand side, and its asymptote is there. Does the solution set still hold true? So let's look for where x is less than negative a quarter. So here's my, you can't really see where I'm pointing, negative a quarter. Where x is less than negative a quarter, is the black greater than the blue? It's pretty hard to highlight, but I'm looking at this piece right here. Is the black greater than the blue up to negative a quarter? Yes, it is. And is the black greater than the blue in this piece right here? Is the black greater than, that's what we're doing, yes, black greater than the blue. Is the black greater than the blue? And it is, because the black is way up here. See, here's the black, and the blue is way down here. Oh, that still came up in black. It's supposed to be blue, but it's not going to blue. There we go. Blue. There's the blue. Oops. So yes, the solution set is still true. So whether you graphed if the question asks you to graph, whether you graphed the very original question I had at the very beginning and you looked for where one is greater than the other, or you created a corresponding function by bringing things over to one side or the other, you're going to get the same answer every time. So even though you would have different graphs, the solution set is still true. Example 2. Solve the following and show your solution on a number line. Write the solution set in interval notation. Okay, so this is a weird one, right? This one looks kind of different. Again, the fraction, some of us might tend to start thinking, let's cross multiply, let's get rid of that fraction. We can't do it when we have an inequality, only when we have an equality. So restrictions, x cannot equal 0. Now let's bring everything over to one side. Bring it all over to the left. That's going to keep our leading coefficient, which is a 2. It's going to keep that one a positive. Bringing everything over to the left. What do we do now? We look for a lowest common denominator, which is x. So now I'm going to start writing my answer in here. Lowest common denominator is x. Let's get our common denominator. So we want a common denominator of x. So I've got 3 pieces. Let me just write out 3 pieces. This piece over x, this piece over x, and this piece over x, which is already done. The 19 is already done. The 0, no, leave that. You put it over x if you want to, but it's still going to be 0. What are the numerators going to be? So I'm going to take 2x, and I have to multiply it by x over x. So that's the same as 2x squared. If I reduced this, just this monomial, just this piece, 2x squared divided by x, it's 2x. So these two are the same. Now 12 is the same as what over x? That's the same as negative 12x over x. So we can put it all over one denominator. Now we've got our common denominator, x, less than or equal to 0. And my numerator is 2x squared minus 12x plus 19. Okay. How are we going to find a solution here? So remember the previous examples, it was based on the denominator restrictions, which we've already got that as 0, and the zeros of the numerator. What are the zeros of my numerator? Well, can we factor it? Is there anything that multiplies to 19 times 2, right, and adds to the middle term, negative 12? So there isn't. Let's take a look at the discriminant here. The discriminant, this is a quadratic. We have so many tools to deal with quadratics. Let's just look at the discriminant. Discriminant is b squared minus 4ac. Let's just see if we're even going to get any answers here. So we sub that in. B squared is negative 12 squared minus 4 times 2 times 19. Barely fit that in there. What do we get? Get out your calculator. And we get a negative 8. That means there's no zeros. There's no zeros. But take a little look at that. Now put together all that knowledge you learned from grade 10 and grade 11. If you just had this function in grade 10, you would be able to, if you do the quadratic formula, you're not going to get any zeros. Does it open up or down? It opens up. So since it opens up and we have no zeros, that would be, let's do a little sketch here, something like this. It's always going to be positive because it opens up and there's no zeros. So this, no matter what you sub in for x into that top quadratic, you will always get a positive, no matter what you sub in. Always positive. Write that down. It's always positive. So what do we do next? Well, we do the same thing we've done before. You've got a few different strategies now. I'm going to do a quick chart. My important values across the top. Negative infinity is always the first number. We only have a 0 from the denominator, which is 0. And then I have no other zeros or anything, so I'm going to go right to infinity. Down the side of my chart, I'm going to put the factors. So I have to write the whole numerator as one factor here. Let me change colors. So this was my numerator. 2x squared minus 12x plus 19. That whole factor is 1. And then I had an x in my denominator. Okay. And then my final column, I'll just give it a double line there for total. My final column will be my related function here, f at x. The original question was not f at x. There was two pieces up there at the top. I've put it all together into one. So let's turn this into a chart here. Whoops, those aren't very straight. And across here, I'm going to, I put my lines in the wrong spot. Sorry, let me erase that. It's a little easier, I think, if I put my lines right below the important values. You don't have to. You can do them the way I just did them before, but I think this one's a little easier. So now let's get some test values and just put them in the space in between negative. So these are easy. I'm going to use -1 and 1. I sub in. Remember this, no matter what I sub in here, remember we already figured this out, but if you don't believe me, you can sub in the -1 and the 1. You're going to get a positive both times. It's always going to be positive no matter what we sub in. Now when I sub them into the x value, that one will be a negative, this one will be a positive. So my final answer here, my function will be negative between negative infinity and 0, and it will be positive between 0 and infinity. So our solution says show your solution on the number line. Let me just put it here. Therefore, let's do interval notation as well. X is an element of negative infinity, always a round bracket there. 0, square bracket or round bracket here? Well, it could be a square bracket because the original question has the equal part of less than or equal to. But we've got a restriction. So that rules out the fact that it was less than or equal to. I have to make a round bracket. So remember, round bracket because of the restriction, not because the original question does say less than or equal to, but we can't be equal to 0 because we have an asymptote there. So how do we put this into a number line? Question says in a number line. So we're going to draw a straight line here, And now we're going to put on our important values, which we don't have too many of them. We've got negative infinity, 0, and infinity. So on the number line, you can always put in a few more here. If you have to show a solution on a number line, we can just, it's always nice to show a little bit more. It helps us to see a little better what direction we're going in. So I'm just going to add on a few numbers here. So we're trying to show negative infinity to 0. To do that, I put an open circle on 0, not a closed circle. An open circle means we are excluding the value of 0. We're not including it. And then I just kind of draw an arrow over. I don't have to go all the way over, but I just draw a bit of a thicker arrow so I can see it over my line here. That's your solution set on a number line. That's all you have to do for the number line. The question didn't ask you to graph it, but I always find that if we talk about a graph, it helps make a little bit more sense of what we're trying to do, and we always end up graphing everything anyway in this course. So I'm just going to take 1 minute, 2 minutes maybe, to talk about it. Right here, I've put in, you can barely see it, but there is an asymptote here at 0 for that. Now, where does this asymptote come from? That's because right here, we will have an oblique asymptote. I went ahead and did the division for it and got the equation, but if we were to graph this, which we don't have to, so I didn't put a lot of time into this, 2x squared minus 12x plus 19, if you did all the work to that, you would get 2x minus 12, and that would be your oblique asymptote equation right there. So, and then we know there's no zeros, so it's not going to cross the x-axis anywhere. So you could sub in a few values. We're not going to we could talk about end behavior around the asymptotes again, but this graph is basically kind of looking like this, here and here. You didn't have to graph it, but it kind of helps you to see the answer. The question, the answer that we got was from negative infinity to 0. So this is when our graph is less than or equal to 0. So it's less than or equal to 0 right here. So this last one is a question from your textbook. We're just going to start it together so that you can finish it. How do we solve this? We've got absolute value. So let me remind you of what absolute value does. Let's take a very simplified version of this question. If let's say the question was absolute value of x is less than or equal to 1. Let's say that was a question. Could x equals 7 work there? Yeah, I could put a 7 in for x. 7 is greater than or equal to 1. Yeah, that works. What about if x were negative 7? Would that work? Remember, absolute value, when you sub it in, if I have the absolute value of x and I'm going to sub in a negative 7, absolute value brackets, their operation is to take everything, take your final answer that's inside and make it positive. So that's equal to 7. So yes, negative 7 works as well. So we have kind of two scenarios. We have the positive that works and the negative that works. Case 1 and case 2 is how we're going to start off. Case 1 is when I take the original question that I was given, I just drop off the absolute value. So that means the positive version. That means if whatever we sub in for x, in case 1, whatever we get for our answer down here, whatever we sub in, everything works out to be positive. That's like the 7, where this is the positive scenario. Case 2, I should erase some of this stuff so you can see it a little better. Case 2 is when we get the negative 7 scenario. When we have the negative 7 scenario, we sub in a negative 7. In order to make it positive, we're going to take that and multiply it by negative. So if I sub a negative 7 into absolute value, I have to multiply it. Algebraically, what I need to do is multiply it by a negative to turn that into a positive. So that's the same question, but we're going to put a negative in the front. So two scenarios. One is where the right answer works, the value for x works fine, no problem. The other one is it'll work if we make it, if we multiply it by a negative to make it positive. So what are we going to do here? We're going to bring the 1 to the left side and find the lowest common denominator. Okay, let me get a color here. So I'm going to start with case 1. I'm going to bring the 1 over. That gives me x over x minus 4 minus 1 greater than or equal to 0. I need a lowest common denominator. The lowest common denominator will be x minus 4. So 1 is simply x minus 4 over x minus 4. So now my common denominator, I can put it all over one denominator, which is x minus 4. And my numerator is x minus, distribute x minus x plus 4 greater than or equal to 0. So we end up with 4 over x minus 4 greater than or equal to 0. There's our corresponding function. So now we have to continue on to solve. You can use the chart, or you can use the kind of fast kind of number line with checkboxes thing if you want here. Let me just put a chart up really quickly. So my important values are, I didn't put my restriction over here. Sorry, I should have put that x cannot equal 4. So my important values here, that's the only one, x cannot equal 4. So I've got a negative infinity, a 4, and a positive infinity. Draw my lines down from there. Oops, that one's. And then down the side, I've got my factors. I've got a positive 4 and an x minus 4. And then my answer will be, I'll call that f of x. So I don't have to actually put that factor of the positive 4 there because it's a positive 4. It's always going to be positive. That one's always going to be positive. I don't really need to put it there, but I don't want to confuse it by not putting it there. So I'm going to put it there anyway. So let's get some numbers. In between 0 and negative 4, I'm going to pick, in between negative infinity and 4, I'm going to pick 0. In between 4 and infinity, I'm going to pick 5, and I'm going to sub those in. Subbing the first one here, remember this is just a factor of 4. I can't change that. It's positive. Doesn't matter what I sub in there, it's positive. But 0 minus 4 is negative. So the function during this interval will be below the x-axis. I sub in a 5. This 4 is always a positive. 5 minus 4 is positive. So this is a positive. Now the question, look at your related function here. We were looking for where all of this is greater than or equal to 0. So this is my answer right here. So my answer, let me put it in red, is when this part gives me an interval notation 4 to infinity. I'm using a round bracket around the 4 because even though the question has greater than or equal to in it, that's a restriction, so it can't be 4. Now there's another part, another whole half to this question right here. We're going to do case 2. Well, we're not going to do case 2. You're going to do case 2 because this is a question from the homework. So you can finish this now. I just want to do one step with you because of the negative sign in front. You have two choices here. You can distribute the negative in. So you can write negative x over x minus 4 is greater than or equal to 1. Or if you decided to say, I'm going to divide this whole side by negative 1, divide this whole side by negative 1, then you would have to flip the inequality. You would have to do it that way to get rid of this negative 1 here, and then we'd have a negative 1 on that side. So you could do that either way. Anyway, once you get started on that, you're going to follow the same process we did on the left side with all of the chart and everything. Bring this over to one side, bring it over to one side, find the lowest common denominator, and then continue on. The same process. You will find your chart is different. You're going to get more answers here than we did here. So you be a little more focused there. Once you're done today's work, a bunch of corrections in your textbook, right? That publisher, wow. To prepare for tomorrow's lesson, you need to watch these videos in advance. So just take a look on D2L to find the links to those. There you go. More fractions. You guys are getting really good at this now because we've done so much work with fractions now. You have lots of strategies. So keep up the great work.